Hi guys, can you see me?
Yes, ma'am.
Yes, ma'am.
Yes.
Yes,
All right.
ma'am.
Nice to hear your voices. Guys, I know the answers are at the back, but just to make sure you know it, and then I'll just show you what you did last year. You will have maybe forgotten, but I know you did it last year. So today I'm just looking at simplification. Simplify using exponents. I'm not going to do equations today. So, you know, if you look at your textbook and you move over, they go straight into exponential equations, then they come back to simplifying expressions. They're a bit all over the place. So I'm just going to stick with simplify. We're doing exponents, no calculator. And remember, it will always, we must leave our answers with positive exponents. They don't always tell you that, but it's implied. All right, so I asked you to try and do exercise 1A to I, and 2A to G. Now, most of these examples are on a level of grade 9, with 1 or 2 grade 10. Sorry, that was my ruler. So these will go quick for me. So let me quickly show you what you had to do, and then you can mark it. It was 5 times a to the naught plus bracket 5a close bracket to the naught. So if you remember, I showed you this yesterday. That 5 has a goes 1 exponent. A to the naught is 1, as long as a is not naught. And then the whole bracket is to the naught. So that whole thing is 1. So you've got 5 plus 1, so the answer would be 6. If I look at number B, we have minus 2, x to the exponent of 3, y to the exponent of 2, raised to the exponent of 3. This is all grade 9, guys, even grade 8. Any negative raised to an odd exponent will stay negative. 2 to the exponent of 3 is 8, because it means 2 times 2 times 2. Remember, when you have a base to the exponent raised to the exponent, you multiply the exponent. So that is 9 and multiply 6. So when you raise the exponent to the exponent, you times, you do not add. All right, so those were the first two, A and B. The answers are at the back of the book. I didn't check to see if there's an error, so if there's a problem, just SMS me. The next one was 3 to the 3. That was in a bracket, squared, dot, which means times 3 squared. Okay, so that was the question. So 3 to the power of 2, do you agree that's just 3 to the 6 times 3 to the 2. Same base, write the base, add the exponents. And guys, if they say no calculator, I'm leaving my answer in exponential form. Because that means 3 times 3 times 3 times 3 times 3 times 3 times 3. It's actually a freaking huge number. No one would know that off by heart. I don't even think a child genius. Just for interest, it's going to be in the hundreds of thousands. 3 to the exponent of 8. You see, okay, not quite. It was 6,561. So what I'm trying to say is, if it's no calculator, you wouldn't actually be able to do anything more. Let's look at number D. All right. Number D is 2 times x squared times y times 4 times x 4 y 3 over 6x6 y6. Okay, guys, these will maybe too easy. Maybe after this I should just bounce to the harder ones. Remember, you can multiply in any order. So 2 times 4 is 8. There's your base x. Add, you're multiplying. Add your exponents because you're multiplying. And then we've got to simplify this. So do you agree that 2 into 4, 8 goes 4, 2 into 6 goes 3. So it's going to be 4 over 3. The x's cancel to the exact 1. And those 4 cancel with those 2. So because they want a positive exponent, you might have gone 4 over 3 to the 4 minus 6 is minus 2. But then you're going to have to put that downstairs to have a positive exponent. So I just kind of did it in my head. All right. This is grade 9. I haven't seen anything even grade 10 yet. Even grade 8, depending what school you go to. So this is basics. Minus 12 x to the 3 over 15y to the minus 2, all raised to the power of 2. Now remember, a fraction to an exponent means you've got your numerator to that exponent over the denominator to that exponent. That's what that means. In other words, shower the power. Any negative to an even exponent becomes positive. 12 squared, that means 12 times itself, 2 times is 144. The exponents you multiply to get x to the 6. 15 squared, now that means 15 times itself. So 5 times 5 is 25. 1 times 5 is 5, 6, 7, 0, 5, 1. So 7, 8, 9, 10, 11, 12. So I didn't even know what that was. So that's 2, 2, 5. And then y, if you times it, you get negative 4. But you have to leave your answer with positive exponents. So just bring the y to the negative 4 up to the top. So you're going to have 144 x to the 6. Jump the line, change the sign of the exponent, and over 225. For interest, I just want to see if I can divide those numbers down further. Your Casio will tell you. So if I just go, can you divide 144 by 225? It is 16 over 25. Here is a very nice tip. I don't know if you knew. To see if a number is divisible by 3, did you know you add up the digits? So if you add 1 and 4, do you agree I get 5, plus another 4, I get 9. So I can divide 144 by 3. If you add up 2 and 2, it's 4, and 5 is 9. So they're both divisible by 3. So you see, because you can actually go a bit further, but I personally would just go up, down, 144 divided by 225. So it's going to become 16. The x to the 6 must stay, the y to the 4 must stay, over 25. I just divided each probably, maybe even by 9, but I would have divided by 3, and if they're still divisible by 3, I would have divided them again, or just cheated. They don't know I cheated, because they don't know how good my mental arithmetic is, okay? So, guys, we've had 10 minutes, I've gone through 5. Obviously, our examples in grade 11 are going to be a bit harder than this, but this is good practice, because you haven't done them for a while. Okay. So, we're looking at number F. Now, number F to me is, okay, let's have a look. 10y to the 4 over 4y to the 6 to the negative 2. Okay, guys, I have to explain one thing. There's more than one way to do this. So the way I'm going to do it might be different to how you did it, okay? But basically, if you want to, I normally work inside there first. Maybe we should just still do that, okay? Let's keep one method. So let's keep that. And do you agree, in the denominator, I could say 2 goes into 4 twice, 2 into 10 goes 5, and then those 4 y's will cancel with 4 there, leaving me a y to the 2, but in the bottom, right? Do we agree with that? Now, to make this power positive, you must flip your base upside down. So if you put the 2y squared, but you're not changing the sign because you're flipping the exact base, as you see that exact base, but now the power is positive. So to make the negative power positive, we just flip the base. All right, now that you have that, it just means the numerator 2y squared over the denominator squared. In other words, shower the power. Okay, so 2 squared is 4, and an exponent raised to an exponent, you add the exponents. And 5 squared is just 25. Okay, so that was number F. All right, hopefully if you did your homework, and I'm hoping you did, try and keep up to date, guys, because if you don't do maths for a week and then you decide you're going to catch up, you're going to get very stressed. I know. All right, number G. Okay, again, we're back to grade 9. Minus 3a squared b4 in a bracket squared over, sorry, that minus is in the bracket, over 3a squared b, and it's just the bracket a squared b that is raised above 3, not that 3. That 3 has a goes 1 exponent. All right, so here you shower the power. Remember, a negative term squared or raised to an even power will become positive. 3 squared is 9. You are not saying 3 times 2. You're going, the base 3 squared means the base 3 times itself that many times. So it's 9. But remember, an exponent raised to an exponent, that's when you add the exponents. Not add, multiply. I wanted to say don't add, but the biggest irony of all is 2 times 2, which is 4, is the same as 2 plus 2. So you wouldn't know there if I added all times, but it's actually wrong to add. You multiply. So just lucky for me, I didn't make a fool of myself, except for I told you, so I probably did. 4 times 2, that would be b to the 8. Okay, the 3 must stay untouched, times, raise the exponent, so that's a to the 6, b to the 3. Why b to the 3? Because the b has an exponent of 1, and 1 times 3 is 3. Now, if you leave your answer like that, you will not get full marks. You've got to simplify. Remember, 3 divides into itself once. 3 goes 3 into 9, so we have a 3. Look at your A's, A4, A6. So they're 4 there, 6 there, so they're going to be A2 left there. Cancel out all 4 and 4. I'm left with A2 there. And then 8 minus 3, you see I'm left with b to the 5. I went 8 minus 3, that's positive. If the bigger number's at the bottom, then you're going to be left with values at the bottom. If you wrote 3a to the negative 2b5, you see you haven't made your answer with a positive exponent. Are you okay so far, guys?
Yes, ma'am.
Okay, cool.
Yes, ma'am.
Good, good. Let's look at number H. A, B, C, D, E, F, G, H. H. 3x to the 3 times 3x to the 3, but notice it's joined by times squared. Because it's joined by times, you can still shower the power. It's just if that was a plus, then you can't. Because if that was a plus, then it's FOIL, a binomial squared. But this is all joined by times. Sorry, let's make sure you can still read that. And then there's a big fat plus. Oh, I see what they did there. I'll tell you who this question reminds me of. This is a typical Miss Ace question. I remember Miss Ace in grade 10. She always gave you, like, I was always watching her exams, the same sort of expression, but joined by times or joined by a plus. Little subtle differences. So, yeah, I don't know if you remember. Okay, so if we square 3, do we agree we get 9? The x to exponent of 3 multiplies, so 3 times 2 is 6. And I've already times that 3 by 3. And there I'm going to get another x to the 6. So before I do this, I can actually write that as 9x at exponents 12. All right? Now, this means you've got the bracket 3 plus 3x to the 3 squared. But before I do FOIL, notice they're exactly the same. So you know what? Why don't we just add them? So we don't, if that was 2x squared or something, I'd have to write the bracket and do FOIL. But because they're exactly the same, it's like having 1 apple plus 1 apple. So I have 2, what I'm calling an apple. All right? So I have 2 of these oaks. So 3 plus 3, you see, I mean, it's just 6, but I've still got to square that. I don't know why I'm doing this such a long method. Anyways, we're getting there. So basically 3 plus 3 is 6 of those guys. Guys, I should have just gone from there to here. 3 plus 3 is 6 of those guys. 3 apples plus 3 apples is 6 apples squared. Finally, but you can shower the power. So we're going to have 6 squared is 36. 6 times 6. Multiply the powers, so we get that.
Ma'am, wouldn't it be 81x to the power of 12 plus 36?
Which one, laptop?
You said 9x to the power of 12. Wouldn't it be 81?
Yes. Oh, you know what I didn't do? Yeah, yes, look at that. Did I? Wait. You know what? You turned to me right. Because you know what I think? You know what I should have done? I should have done what I always do, is just let's neaten that up. So 3 times 3 is 9, x to the 6. And then I've got to square that. So you turn to me right. 81. And then 6 times 2 is 12. Okay? That was, you know what? That's the worst example I think I've ever done in my life. And here we got 36x to the 6. Let me just double check that. So 3 times 3 is 9, x to the 6 squared, 9 9s are 81, x to the 12. Okay, and then this is 6x to the 3 squared, which is that. And guys, you cannot add those. That is 81 airplanes plus 36 buses. Am I right? Is that the answer, Lamb Chop? Is that what you got?
Yes, ma'am.
Maybe.
Yes, ma'am.
I made a stupid error there.
Ma'am,
Yes, Lamb Chop?
can you factorize it? Oh no, you just leave it.
Don't, I tell you why you mustn't factorize, because they're asking you to simplify. So theoretically, we don't want brackets.
All right.
Yeah. Okay, the only time you have brackets with the simplify is with like algebraic fractions. If I give you x squared minus 4 over x plus 2, then that's dots. So they would say, yes, simplify.
Oh, yeah.
That's when you would factorize. But you'd be left with that answer, okay? If they say simplify, yeah, you could theoretically factorize, but then if I did take out a common factor, I can definitely see 9 is common, and I can see x to the 6 is common. Then you'd be left with 9x to the 6 plus 4, and do you agree to simplify? That's not simplified. You'd have to do that, which comes back to that answer. So in other words, when you ask to simplify, get rid of the brackets. You only keep brackets if it's in fraction form. Does that answer your question?
Yes, ma'am.
Cool. All right. Anyway, I made a stupid blunder of that question. Let's put the glasses on and keep them on so I don't not see this. Okay. Number I. This is a little bit trickier. I think a grade 9 would go wrong with this example. Because if you were listening yesterday, I have 2 termies there. So because you've got 2 termies, you cannot bring them up. So that's where I would say I have my numerator, which is x plus y. Remember, division line is a flat bracket, divided by my denominator. All right. Then I would keep my numerator. I wouldn't even do a times and tip yet. I only times and tip when I get the second term to be 1 term with 1 numerator and 1 denominator. So do you see this is 1 over x. Now the power is positive. And this is 1 over y. So notice how I handled that. Now, again, I'm not going to go into times and tip. I'm keeping it as divide because I need the LCD of xy, which you cannot drop. And then x divided to xy will go y, plus y into xy goes x. Now I have one top and one bottom, and that's over a 1. There is x plus y over 1. Now you can change your divide to times. Flip this upside down. Do you audibly y plus x is the same as x plus y? It's exactly the same. And then using a pencil, do you see, lamb chops? That factor cancels out with that factor. And your final answer for the last one would just be x, y. That's the only example that would be grade 10 and not grade 9. I can't see them giving that to a grade 9, but as a grade 10, very popular question. Do you remember doing something like that last year, guys?
No.
Oh, well, you should have.
I
All right.
remember doing something like that in the practice papers my mom printed for me.
Yeah, you saw something like that.
Yes, I've seen a lot of other stuff in those practice papers.
Yes, you're right. So if you do practice papers, you write Tande. Oh, well, anyway, I know who that is. Okay, chicken. All right, so yeah, okay. So let's move on with number 2. Okay, now 1 to any exponent is 1. So if you have 1 to the naught, it's 1. 1 to the power of 9,999. It means 1 times 1 times 1, 9,999 times. So it's still 1. Even if you had 1 to a fraction exponent or half, it means the square root of 1, which is 1. So for 2a, they gave us 1 to the 2011 divided by the number 2011 to the minus 1. So they're trying to trick you. 1 to any exponent, that's 1. But that number is 2011 to the minus 1. So if you jump the line, you change the sign of the exponent. So that becomes positive 2011. See, to the ghost plus 1. So I don't need that ghost and I don't need that ghost, which means your final answer is just 2011 positive. They're trying very hard to trick you with that question, but because it's Tuesday, I'm awake. I am not going to get tricked by that question. But again, it's not actually considered grade 11. That's still grade 10. Let's move on to 2b. Okay. Right. 0,125 to the minus 3. Now, if you ever get decimals, you must write decimals as fractions like a over b. All right? If I have a good memory, that is 1/8. But if you don't know that, you could just go 0,125 equals, and the Casio will tell you it's 1/8. Now, it's in a bracket, please, raised to the -3. All right, now, let's make that positive exponent, let's make the negative exponent positive by flipping the base. So if you put the 8 in the top and the 1 at the bottom, I flip the base, and now the exponent is positive 3. So that means you got to shower the power 8 to the 3 over 1 to the 3. Now, 1 to an exponent is 1. So 8 to the 3, I'm not actually sure. I think I'm going to leave my answer as 8 to the 3. Just so you know, 8 squared is 64. But 8 to the 3 means 64 times another 8. So 8 fours are 32. 6 8s are 48, 49, 50, 51. So if I'm not mistaken, 8 to the exponent of 3 Yeah, it is 512, but you know what? I don't know, and then it's over a 1, but anything over 1, okay, so you know what? It's fine. If you left it as 8 to the 3, I'm sure you would have also got it. All right, but notice that we got out of decimals, we put it into fractions. Let's quickly look at number C. So we're on 2C. Okay, this is just too easy really, but let me just do it fast. I'm not going to talk much. Everything's joined by times. So guys, it's 6. I'm going to bring that down 2 to the positive 2. I'm going to bring that up 3 to the 3. So that's 6 times 27 over 4. 2 goes there twice, 2 goes there 3. So 3 times 27 is 21, 81 over 2. I think that's the answer. You know, you can check that using your Casio, quite frankly. So 6 times 27 equals divided by 4 is 81 over 2. Okay, that, you won't get something like that. Number D, you got 1 over 4 to the minus 3x times 8 to the 2 minus 2x. Okay, these are getting more interesting. So what would I do here? Okay, I'd flip my base. I'd make my positive exponent, my exponent positive. Okay, I think for 8, I'll break it up to 2 to the 3, break into prime, raised to that. Okay, I'll just check that that's right, okay. Even 4, degree 4 is just 2 squared, raised to that exponent. Now distribute, multiply, so 6 minus 6x, and this is going to be 2 to the 6x. And then guys, do you remember that rule? If you have the same bases, you write your base, add the exponents. Now plus 6x added to minus 6x, that cancels out, so we're left with 2 to the 6. 2 to the 6, I know is 64, but you can leave your answer as 2 to the 6. So what I did was to make the negative exponent positive, I flipped my base, I broke 4 to 2 squared, I broke 8 to 2 to the 3, and then you have 2 terms as your exponent, so you've got to distribute it, same bases, don't multiply, you just write your base, then you add your like terms. Okay, so we have 10 minutes left and I'm on 2E. Okay, as far as 2E, I don't know about you, but I'm sick of purple.
My neck hurts. Yeah.
Hey? What am I right? I thought I changed to blue.
I didn't say my brain hurts. I said my neck hurts.
Your neck? Okay.
No one cares.
No, I didn't say you said anything. I'm just going to do 2E in blue. 8
You
times
stupid.
9 to the 3. 32 squared. Now guys, in maths, that is times. I'll never forget once, one of my matrics thought that was 8,9 to the 3. It doesn't even make sense. So guys, with this example, I'm going to break into prime factors. This is a typical example that when you get everything joined by times or divide, break your numbers into prime. Okay, break the numbers into prime factors. Okay, if everything is joined by times and divide, which it is. So 8 is just 2 to the 3. 9 is 3 squared raised to the 3 over. 32 is 3 to the 5 raised to the 2. And 27 is 3 to the 3. So we've got 2 to the 3 times 3 to the 6 over 3 to the 10 times 3 to the 3. Now, wait, that was a 2 to the 5. Sorry, 2 to the 5. Now, they will know if you cheat because 2 to the 10 is a damn big number. But you understand 2 to the 3 means you've got like 2 times 2 times 2. 3 to the 6 is like 3 times 3, etc. over. So do you see, this is where you can use that rule 2 from yesterday. If you have the same base, write the base, go top exponent minus bottom exponent, times, let's look at the base 3, top exponent minus bottom. Now there's a 1 there. So here you're going to get 2 to the negative 7, and here you're going to get 3 to the 3. Now you can't leave your answer with negative exponents. So do you understand the 3 to the 3 will stay here. Now go 7, 2. I can cheat there. Like 200 and something. 2 to the exponent of 128. Okay, if you left your answer like that, I'm sure you'd get full marks. Okay, I have a little bit of time and I'm really near the end, thank goodness, because these are just getting a bit irritating. They're too easy. If you're not finding them too easy, you just don't know your rules. Okay, everything in maths has a rule, promised. Okay, I'm now on F, which seems ridiculously easy. I don't know why they even gave me that. Maybe it's because you think that maybe that's a times, it's a plus. So that's just 1 over 2. Now my power is positive, not negative. Plus 2 to the 4 means 2 times 2 times 2 times 2, which is 16. That means 1 to the exponent of 4 over 2 to the 4. Remember, shower your power. But remember, 1 to any exponent stays 1. So it's 1 over 16 plus 16 over 1. Now you cannot cancel. This is where you go into an LCD, which you can't drop. And it would be 1 plus 1 into 16 goes 16, and 16 times 16. So you're going to get 1 plus 6 sixes are 36, 1 6 is 6, 7, 8, 9, 0, 6, 1, 6, 5, 2. Okay, I'm just going to check this now using my calculator. Remember, you can always check your answer using a calculator. I'm just going to go back to that step and go up, down, 1 over 16 plus 16, and I get 257 over 16. Okay, 100%, no calculator. You might say, but man, you checked your answers. As long as there's no decimals, you get 100%. If you said the answer is 16,06, I would give you 0 on the spot, because how the hell would you know that? Okay, so lamb chops, we're running out of time. We have 4 minutes left. Are you still there? Hello?
Yes, ma'am.
Cool. Okay, let's do number G. Super similar like to the previous one. We've got 1 over 3 to the minus 1 plus 2 to the minus 2. Now, because there's terms, you cannot bring these up. So this is the same as your numerator divided by the denominator. But this is just 1 over 3, and this is 1 over 2 to the positive 2. All right? So we've got 1 minus a third plus 1 over 4. Do you see there, guys?
It's not minus, it's divide.
Sorry?
Ma'am, you.
Oh!
Yeah.
Yeah, so very well spotted. Okay, was that Nelly again?
Yes, ma'am.
Yes. Okay, well done.
Why are you lying?
Okay, that there is a divide. All right.
Oh,
LCD 12, 3 to 12 goes 4, 4 to 12 goes 3. So it's 1 divided by 7 over 12. Okay, now this is where you go 1, change the divide to times, and tip. And the final answer, did you get 12 over 7? Yes or no, or maybe? Was that the answer at the back?
Sometimes.
What do you mean sometimes?
Maybe.
Kind
Okay,
of.
well, you know what? I can check that
Okay.
using my, look how sneaky I am. I'm going to go up, down. I'm going to go 1 over 3 to the exponent of -1. Go across plus 2 to the exponent of -2 equals, and guys, I get 12 over 7. So, yeah, I'm right. So, do you see you can use your Casio to check?
Sometimes.
Okay.